Are you tired of your ports connecting to another person's phone while you are studying? Worry not, RC Enterprise has brought you quality AirPods that are going at 200 kwacha only. Come and grab yours at Chambeshi 43, the hostel that is just opposite Mount Peposo. Ladies and gentlemen, in this tutorial we are going to learn about limits and continuity. What should come into your mind when you hear the word limits and continuity? From the word itself, you can actually differentiate to say they are talking about the end of something. For example, we have been given this question which is saying the limit as x approaches 2 of this function, which is x over 2. There are two methods in which we can work out this one, but in this case we start with the first one, where we get a number that is closer to actually 2. In this case, when we get a 2.1, when we replace where there is x with a 2.1, we find that we are having a 4.1. When we get a number that is again more closer to 2, we find that we'll get actually a 4.01. So this should actually tell us that as we are approaching x to 2 in this function, we are getting closer and closer to 4. So the limit as x approaches 2 of this function is actually 4. But there is also an easy way of doing things where we'll get this same function. We fact out this thing where we are having x minus 2 over x minus, so this thing will cancel each other, so we will have a x plus 2. So as we approach x plus 2, here we have a 2 plus 2, which is actually 4, like it gave us in the previous question. So we also have another question that is x squared plus 2x minus 4 as x approaches 5. So when we see that when we replace directly here, we'll find that we are getting a 31. So as x approaches this, we are getting a 31. The reason in the first place that why we didn't, it should give us a defined number. For example, if it gives you 0 over 0, it means it's undefined. You need to factor out. So in this case, it's just given us a direct number. It's actually defined. So we also have x cubic over 27, this, yeah. So as x approaches 3, so in this case, when we get it, we'll have a 0 over, when we replace direct, we're having a 0 over 0, which is actually undefined. So we need to factor out the top part. How do we factorize this one, the top part? Save this. We have the formula. You should save this formula. Factorizing this top part, we have this b over a squared plus a b plus b squared, where actually a represents x and b represents 3. So in this case, we have 3 to the power 3, which is actually 27. So b actually here represents 3. This is how you go about factorizing the top part. You should master this formula. It should be in your heart. So when we save this, don't trouble. When we replace where there is a, we replace with x, we find that we are having x, and where there is b, we find that we are having 3. close brackets. Where there is a again, we replace with x squared. Where there is an a, we replace with x. Where there is b, we replace with actually 3, and plus b again, which is actually 3. So when we approach, mind you, here we have an x over 3. So we have factorized the top part. This will cancel each other. We only remain with this part here. And when you place a 3 in where there is x and where there is b, we replace a 3 here. We replace a 3 like we did on this side here. We are finding that we are having a 27. So the limit of that function is actually 27. So we also have certain cases where we have x over this 1 over x minus 3. We have this. They tell us to find the limit of x as it the limit of the function as x approaches 3. So we notice that on top we have fractions. The first thing that we should do is actually multiply the lowest common denominator of the fraction, which is 3x, also multiplied down here by 3x. So find that you have on top here, when we multiply here, we have a 3 minus x over 3x minus x minus 3. So we find to say this is what we have. The down part, let us not do or temper with anything. So this thing here will just be 1 and the same when we factor out the negative here. We factor out a negative, we find that we are having an x here minus 3, just 1 and the same. So we observe that the top part and the bottom part, they look similar, so they cancel each other. So down here we find that we are remaining with 1 over 3x. So now it is possible for us to approach x to 3. So we have 1 over negative 9 as our limit in this case. So don't forget, we started by multiplying the lowest common denominator of the numerator on both sides. So we came up with this. So after coming up with this, we noticed we wanted to make the denominator this and the numerator this to be similar. That's why we factored out a -1 here. So after factoring out a -1, we remained with this. Now it became similar and it cancelled each other. We remained with a -1 over 3x, and that's now it was suitable for us to actually replace where there is x, we replace with 3 to get a 1 over -9. So we have also another case where we have a square root of 3 of x over x minus 9 as x approaches 9. So notice something, when we just replace directly, we find that we are getting a 0 over 0, which is not the case that we want, which means it's undefined. But how do we deal with this problem? How do we deal with it? So the first thing that you should know is notice something here. You have a square root minus 3. So the first thing that you should do is actually multiply actually by the conjugate which is actually a plus 3 over x plus 3. So when we multiply this with the top part, save this, don't rub. When we multiply this with this and this with this, find that we are getting x plus 3 minus 3x minus 3. So we'll get the down part, we won't temper with it, but we multiply it, but we won't temper with it. So when we find that this one and this one will go, we'll remain with an x minus 9 over x minus 9 with the denominator plus 3. So notice something, this one will be similar, you cancel each other, we will remain with the top with 1 over the x plus 3. So right now it is possible for us to approach x to 9. As x approaches 9, so it won't give us a 0. We have this, which when we replace with 9, we have this, which will actually equal to 1 over 6. So the limit of that function that we are given, hope you did not rub it as well, is actually 1 over 6. So that's the basic knowledge that you should understand about limits. Don't forget to subscribe the channel and join the WhatsApp group for more updates.